So in this video, we're going to look at beta evaluation metrics. In the previous video, we just looked at logistic regression. We built it, we calculated the log loss, and then right at the end, I talked about precision and recall. And I said I'm going to come back, I'll record a video and explain what those mean, and then we'll do the other models. So let's just quickly explain those and build our knowledge as to why we ended up drawing those graphs at the end of the logistic regression video. So it was log loss. When you looked at it, it's not very intuitive. It's difficult to really understand what is going on with log loss, because as data scientists, right, we work for business. That is the honest truth. We work to solve business problems, and when you go to your CEO or your business leader, it's difficult to say, oh, my model had a log loss of 0.1. What does that mean for business? What does that really mean intuitively? It's difficult. So we need better evaluation metrics. And this is where this video is coming in, and those graphs that we plotted. There's something called recall and precision. And we talked about that in the previous video briefly. Recall is defined as the number of cases. I'm just going to write number of cases. So it's going to be number of fraudulent cases that we catch out of the total true number, TRUE, true number of cases. So out of all the true number of cases, how many cases did we catch? That is your recall. And then your precision is defined as number of cases we correctly predicted, or we correctly caught. So our model is going to predict some cases as fraud. It's going to give you some number, and then of those cases that we have predicted, how many of them are correctly predicted, how many of them are true. So there's a bit of a difference. It might be confusing at first, but I hope you can research this. You can research this better, especially if you go through like your supervised learning. This will be hammered in. This will be hammered in. So recall is going to be out of all the true cases, how many did we catch? Precision is just going to be of the ones that you caught, how many are correctly predicted. We can see we can talk about something called a confusion matrix. Maybe that will make it much easier, right? Confusion matrix. So let's set up something here. Here we're going to put our predictions. So here we're going to say true. We've predicted a true. Here we've predicted a false, right? And then on this side, what we're going to do is, on this side, what we're going to have is the actual. So this is the true. If I say true, it's going to confuse with true. So this is the actual, the actual state, and here it will be either true or false. So what we're saying here is we're predicting fraud. So in this case here, when I say true, fraud, and this is non-fraud or no fraud, right, for that transaction. And true here is going to be fraud, and there's going to be non-fraud, right? So let's fill in this matrix. If we have predicted if we have predicted true and the actual is true, that is called true positive. It's a true positive, right? Because we have predicted true and it's actually true. And if we predict true but it's actually false, that is called a false positive, because we have falsely predicted it to be positive. We have falsely predicted it to be positive, right? And then if we predicted false but it's actually true, which means we have falsely predicted it to be negative. We falsely predicted it to be negative. It is actually true, but we have falsely predicted it to be negative, right? And then here, when it's false, this is a true negative, because we have truly predicted it to be false when it is actually false itself. So that's the confusion matrix that we'll be dealing with to discuss precision and recall, right? So let's get into the detail now. The way we are going to define them is, especially in unbalanced, when your data is imbalanced, when your data set is imbalanced, it is not good to use accuracy as a measure. Let's see what accuracy does. Accuracy is how many did you get correctly, and that's your true. You see, your true positive, you got it correctly, so that's your true positive plus your true negative, because you got those correctly, you predicted them as correctly negative, divided by, let's just say n, which is your number of observation, or the sum of all these. That is your accuracy measure. But when your data set is imbalanced, right, just imagine you naively, you're like, I'm tired. If someone comes to you and then says, for this fraudulent case, let's build a model, and you are lazy, and then you just say, I'm going to build a model that just predicts that all of the transactions that are coming in are not fraudulent. They are not fraudulent. Every transaction that comes in, it just predicts not fraudulent, not fraudulent, not fraudulent. So which means for our data set, right? Our data set, let me actually get the proper number. Our data set is 284,807 transactions, right? So for you, you're going to predict that all of them are not fraudulent. The ones that were fraudulent were 400. Let me get the number again. 492. 492 were not. 492 were fraud. 492 were fraudulent. But you have predicted that all of them, these are fraudulent. Which means that how many have you correctly predicted? It's going to be 284,000 minus the 492. So which means you have correctly predicted for 284,315. So these are your true negatives. These are your true negatives, because you said all of them are not fraudulent. So which means your true negative is going to be 284,315, right? True positive, you do not have any true positive, because you forced every transaction to be negative. So which means your false positive, you predicted it to be false. You predicted it to be false, but which is actually true. So here you have your 492, which is a false negative because it's actually true. So you have a 492 there. When it comes to measuring accuracy, you're going to say true positive, which is 0, because you didn't catch any fraud. You said all of them are not fraud. You didn't catch any false positives because you were not caring about that. So you're going to say 0 plus 284,315. That's your true negative, divided by everything that is in the dataset, 284,807. So your accuracy is going to be 99.9% So without even building a machine learning model, you have already predicted with 99.9% accuracy. But we know this is misleading. It is misleading because we do have fraudulent cases here. Imagine if those fraudulent cases were, each one of them was a billion rand, which means the business would have lost 492 billion just by you not predicting that correctly. So you see the impact of accuracy being a very, very misleading measure when you have a data set that is imbalanced, because we are going to get a very high accuracy. The high accuracy is just going to come from the imbalancing of the true negatives just being way more than the positives, way more. As we saw, the positives were just 0.14. I think it was 0.147%. So we need better measures. We can now look at something called precision. Because our data set is imbalanced, let's look at a measure called precision. And precision is defined as true positive divided by true positive plus false positive. That is the definition. That's how you calculate it. True positive divided by true positive plus false positive. What does that mean in English? In English, precision just basically means, let's say, a high precision. A high precision means, it just basically means, of all the ones that you said are fraudulent, of all our positive predictions, the ones that we've said these are fraudulent, of all our positive predictions, many are true positives. That is a high precision. So precision basically is saying, like I mentioned here, precision just says, for the ones that you have predicted, number of cases you have predicted, how many have you correctly predicted, right? So it's going to be for the ones that you have predicted, right? So for the ones that you have predicted, And we want our true positive to be very high. Our true positive to be very high. If our true positive is very high and our false positive is low, we will have a high precision. And a high precision means of the ones, let's say we have predicted that 20 are fraudulent. A high precision will say, okay, of the 20 that you have predicted for me that are fraudulent, 18 of them are actually fraudulent. You know what I mean? This is a better measure of how your model is performing. Of the ones that you have predicted to be positive, how many of them are actually positive? That is precision. And another very powerful one is recall. And recall is defined as true positive divided by true positive plus false negative. And a high recall, based on what we discussed previously, a high recall means of all true positives, it means we have captured, I should have said we have captured most of them. So a high recall means we have captured most of the true positives. So in our data set we do have true positives. A high recall just says your model is capturing most of them. So let's say in our case we had 492. Those are the true positives that we had, right? We had 492, I think it was. Yeah, 492 fraudulent cases. If our model has high recall, it means we're catching maybe, let's say 450. We're catching 450 of them. Our model will have high recall. It's capturing all the true positives. We're capturing many of them. A best solution will have high recall and high precision. That is the sweet spot. But it is difficult to reach high recall and high precision. Let me explain a bit of why. It has to do with there's a trade-off that happens. But let's look at some cases. Case number one, we have high recall. We have high recall. Let me say high recall. We have high recall and low precision. We have high recall and low precision. What does that mean? High recall, from the recall part, it means this model is returning many true positives. It's returning that it's catching out most of the positive cases, right? But low precision. So in the data set that it's returning, yes, of the total positives, you're catching a lot, right? Let's say, so our data set is going to be, when we return the whole data set had how many again? Let me just go up a bit. It had 284,807, right? So we look at our total 284,807 transactions. That is the total, right? So with high recall and 492 were fraud. So in a high recall case, we are returning, let's say 450 transactions that are positive. We're saying 450 are positive. But then because we have low recall precision means even though we are returning 450, we are also returning ones that we think are positive but are actually wrong. Low recall says we've predicted some to be positive, but we haven't predicted correctly. So here maybe we are returning 200,000 to be positive, but we are wrong. They are not positive. Because if you say 208,000 divided by this, we're saying they are positive. They are actually not positive. So low recall says of the one you're predicting all this other junk. You're predicting all this other junk. Dude, to be honest, it is junk. It is not true. It is not true. So that is the case where we have high recall and low precision. High recall just says, okay, dude, okay, the truth is it's not going to be 450. It's going to be, okay, your model is returning 200,000 positives. That's what the model is saying. When it's returned 200,000 positives, high recall says, out of that 200, inside that 200,000, oh yes, you are right, 450 are actually positive. So if you do 450 divided by 492 or whatever, 492, yes, that's a high recall. But if you then look at the precision, it's going to be like, hey, dude, all the other ones that you were telling me, I'm sorry, they are not actually positive. They're actually not positive. They are wrong. And then we have a low precision. So that in this case, what are the implications then? You might ask, okay, so what are the implications when you have a model like this and then you have to tell it to business? What do you tell business? What you tell to business is, in this case, the company is catching out, it's catching most of the fraud. It's catching most of the fraud, which is positive, which means we're not losing money. We're not losing money. We're catching most of the fraud because of high recall. But the second implication is we are going to bore our clients or angry clients because of low precision. The ones that were predicting to be fraudulent, many of them are actually not fraudulent because of low precision. So clients are going to get bored. They are swiping and then we predict it to be fraudulent. They're going to get bored. They're going to get angry because they'll be like, dude, it is not fraud. But our model is, because of low precision, it's saying it's fraud. So that's a bit of a problem here. In a second case, we might have low recall and high precision. Low recall and high precision. What happens in this case? In this case, it means we are not catching much of the positive class, but the ones that we predict to be are truly positive. The ones that we catch, the ones that we predict, the ones that we predict to be are truly positive because of high precision. So what are the implications in this case? Company loses money. Company will lose money to fraud. Money to fraud. Why does it lose money to fraud? Because of low recall. We are not catching much of the true positive because of low recall. So which means some transactions are going through and our model is not catching them. So we are losing money. But we have happy clients. Happier, let me just say happier clients. They're happier because of the ones that we really say, nah, this is positive, this is fraudulent. The one that we predict to be fraudulent, we are truly catching the transactions that are fraudulent. So the clients are happier than in the first case. And in your mind, you might already be thinking, which is the best solution? That depends on your business. It depends on your business, and you have to. The best one is, of course, this situation that we mentioned here. Let me say the zero situation: high recall, high precision. High recall means we are catching out most of the transactions that are fraudulent. Companies not losing money. No, this was supposed to be precision. Sorry, I hope some people caught it. High precision, and high precision then means of the ones that we predict, they are actually fraudulent. Of the ones that we predict, so this is the best situation. Customers are happy, companies not losing money, but it's a difficult one to achieve. It is difficult because if threshold to be predicted as fraud, right? Let's say probability, because we're working with probability. Usually we say if default says if probability is greater than 0.5, call it fraudulent, or give it the positive case, or make it 1. In our case, make it 1. So when we're calculating those probabilities, it says if you catch if the probability of it being in class 1 is greater than 0.5, make it a fraud case. So, but you can play around with this threshold here. You can play around with this threshold. If you make the threshold high, let's say 0.9, many transactions are not going to be predicted as fraud. Because for the transaction to be predicted to have a probability of being fraud more than 0.9, that transaction needs to be very, very fraudulent. You know what I mean? So we are going to catch very, very few. We are going to predict very, very few to be fraudulent. What that means then in that case, oh no, we are not going to predict very few. We are going to catch very, very few. Many are going to go through because their probability is going to be predicted to be lower than 0.8. It will be 0.8, 0.7, 0.88, 0.89, whatever it is. But it's because our threshold is very high, we are going to have a low recall. We are not going to catch as many true fraud cases, but we are going to have a high precision. Because for the ones that we call fraud, they will be truly fraud. They will be truly fraud. For it to be 0.95 probability that transaction is truly fraudulent. So we have a high precision. The one that we predict to be fraud, they will be truly fraud. So we have a high precision. As we lower this threshold, right? As we lower the threshold, we lower it to 0.4, 0.3 or whatever it is. Our recall, many transactions are now getting caught to people, are now getting like, hey, this is fraudulent, this is fraudulent, this is fraudulent. So which means we are now capturing a bigger chunk of the true fraud cases. That's why our recall will start increasing. So as we go down the threshold, we'll increase the recall. But then we'll start blaming other legitimate transactions. Because our threshold is now low. We'll start blaming other transactions that are normal transactions, but because our threshold is so quick to hit, it's so easy to hit, we'll now predict many transactions to be fraudulent when they're truly not fraudulent. So our precision will start decreasing. So we'll start having low precision as things decrease. So as you can see, as we play around with the threshold, we are having the what is it called again? We are having the interchange between low recall, high precision, and high recall and low precision, and that interchange is what we need to play with. Let me see what the actual. I'm trying to the trade-off. The trade-off. That is the word that I was looking for. I don't know. My brain was freezing there for a moment. So there is a trade-off as we play around with the threshold. There is the trade-off. So, and what you can do now, you can plot as you play around with the threshold. You can now plot your precision and your recall values as you play around with the threshold, and you come up with a graph. Let's say a graph like this. Because as you change your thresholds, maybe your precision will start off here with high precision, and as you lower your threshold, you're lowering your threshold, you're getting a certain precision value and a recall value. Here, a certain threshold, we have a certain precision value and a certain recall value, and as the threshold it keeps lowering, your precision keeps going down and your recall keeps increasing. As you can see, keeps increasing. So you end up with a precision recall curve. And you can calculate of all those precisions that were attained throughout all those thresholds, what is the average precision? You can calculate the average precision. And when you calculate the average precision, you'd want a model that is a high average precision. If it is high average precision, that is usually a better solution. And if I just go back to my graph here, if I go back to my graph, you can see we calculated our precision recall curve. That's what I was talking about just now. And we calculated our average precision. So this is the precision recall curve that is showing the trade-off between precision and recall. And our average precision for the logistic regression is 0.74. So that's what this graph means here, the precision recall curve. That's what it means. So in the next video, we're going to talk about the ROC curve. We're going to talk about the ROC curve, and then we'll continue with our random forest. So stay tuned for the ROC curve video.